visual inspection are often able to detect damage like potholes. However, they are less effective in identifying problems like cracks and corrosion. Here are the method advantages and disadvantages of visual inspection. First is the method, inspecting the structure with the naked eye to look for the potholes, cracks, spalling, or etc. Next is the advantages, is an easy and straightforward approach which does not require training. And last is the disadvantages. While a good starting point for expecting bridge damage, this approach does not provide a proper assessment of what is happening on the interior of the structure and only analyzes issues in need of immediate repair. Next is infrared or thermal imaging inspection. Here are the method advantages and disadvantages of infrared. First is the method. This non-destructive practice examines changes in infrared radiation from the surface of concrete and indicate delamination. Next is the advantages. It can be performed quickly and even in mining vehicle. Last is the advantages. This method cannot be performed on bridges with alpha overlays. The data must be obtained when there is a large thermal gradient between the bridge and ambient temperatures.
Coring and chipping method. A destructive technique that uses a drilled core to create a hole in order to connect to the steel reinforcement and assess corrosion damage and mechanical and chemical properties of the concrete. Advantages. Much more information can be obtained about the health of the concrete structure using this method. Disadvantages. Destructive technique can at times be more damaging to the overall structure's integrity. Once data has been collected, the hole must be repaired. Ground penetrating radar or GPR method. This non-destructive test uses electromagnetic radiation to image the subsurface of the concrete and detect changes such as delamination, voids, and cracks. Advantages. Provides reliable and objective quantitative data regarding the health of the concrete structure early on, rather than subjective observation taken during a visual inspection, for example. Disadvantages. Requires high energy consumption and an expert to interpret the data.
Acoustical techniques. Method. This is a non-destructive technique which is performed using a chain drag or hammer to identify changes in sound pitch. The test is able to detect delamination as well as the separation of coating or the splitting of a structure into layers. Disadvantages by using acoustical techniques. The test may not be accurate due to hearing biases, requiring a trained ear for accurate analysis. Bridges with asphalt overlays cannot be tested using this method. Half-cell potential test. This non-destructive technique assesses the voltage between the steel reinforcement within the concrete and an electrode which is placed on the concrete surface to map corrosion activity. The advantages of using this technique is this method can detect corrosion before it progresses to the point of delamination, allowing for early repair. Disadvantage is it can be more costly than the other techniques.
Bridges are important parts of a nation's infrastructure are reliable. Monitoring methods are necessary to ensure their safety and efficiency. Most bridges in use today are built decades ago and now subjected to change in load pattern that cause localized distress, which may result in bridge failure if not corrected. Early detection of damage help prolonging the lives of bridge and preventing catastrophe failures.
Acoustic emission technique. It is non-destructive testing that detects and monitors the release of ultrasonic stress waves from localized sources where material deforms under stress. How does it work? It works by monitoring small sensor into a component under test. The sensor converts the stress wave into electrical signals which are relayed to an acquisition PC for processing.
Some of the advantages of AE technique over other non-destructive techniques are its high sensitivity, source localization capability, and ability to provide monitoring in real time, that is, damage detection as this occurs. Study of AE started in the 1950s, and AE techniques found its initial application in monitoring pressure vessels and aerospace structure. AE was first applied for bridge monitoring in early 1970s, but the use and study of AE for monitoring bridge structures rose with a rapid increase in computing resources and development of sensor technology.
Through AE technique has been successfully applied for bridge monitoring, several challenges still exist. Bridge can create practical problems like, for example, with accessing desired areas for a large number of sensors to monitor the whole structure. Identify critical areas is the solution. For instance, in steel bridge-like sources of AE include crack root. Presence of noise sources can mask the AE signals from real crack as one of the biggest limitations of AE monitoring system.
Structurally deficient, functionally obsolete. Where did the major get these trigger words when describing the condition of our nation bridges? Why do they sound bad? How concerned should we be? Are the bridges identified as one of the categories safe? How do we know the bridges is safe? Who is determining the bridges is safe?
Bridge inspection is important because it actively manages the infrastructures and provides confidence to the owner and to the public for the safe use of the structures. Inspection crews are working year-round, checking conditions, updating findings, performing evaluations and analysis, and preparing current findings reports to bridge owners.